Hello everyone, this is Mrs. Lindsay Pereira. Continuing on, in our packet here, we're on topic 7, solving systems of equations. There's a couple different ways to solve systems of equations. The first method is by graphing. So let's talk about graphing these equations. Well, these two are going to be easier for us to graph than these two. If you, the only reason that these are going to be a little easier to graph is because these are already solved for y. Where number 2, they're not solved for y. You would actually have to solve these equations for y. So let's talk about 1 first. So if I graph this first one, right, I'm going to graph that one in green. So my y-intercept is 3. And then I count out my slope of a half. So up 1, to the right 2. And again, super important, even more important than our last section, fill up your entire graph here. And I'm actually going to do this one in green so I can talk about the different colors here a little bit better. And I'm also going to graph this next one. So y-intercept of -5. Now I have a slope of 5 over 2. So I go up 5, to the right 2, up 5, to the right 2. And again, I'm going to now go off of my graph. I can draw this. Again, please try to use a straight edge off of your calculator or something like that. So what does it mean to solve this system? Well, there are many solutions here to them individually. But we want to know what is the point of intersection. So where do the two graphs meet? They meet at this single point right here. So that ordered pair would be 4, 5. That would be our solution. Okay. So these answers should be ordered pairs for these. And we'll talk about, again, we of course have special cases. Number 2 I alluded to here. In this case, you're going to want to write it in slope-intercept form first, or solve for y. So add over the x, just like you did in the previous lesson. And then you're going to be able to do that form right there. Okay? But let's jump down here to 3. We're going to solve the following system using our calculator. Sketch a graph. Identify the window used. Round any decimals to the nearest hundredth. Okay, so if you don't have your calculator, go ahead and grab that, pause the video, and then we're going to basically enter these in. So I'm going to pull up my calculator here. I'm going to move it over slightly. I'm going to plug in both of the equations. Let me clear that out. So I have negative 12.2x minus 8. My first equation, that's going to be blue, that shows up in my calculator. Then I'm going to have 10x plus 55. And I'm going to always start from my standard window. Standard window, zoom, and then I go to zoom standard, which is number 6. Again, that always makes it go from a y value of 10 to -10, and x value from -10 to 10 as well. So you can see both of these show up on my calculator, but I don't see where they intersect. So we actually have to change our window. And clearly they're going to intersect somewhere above this y value, this y max value of 10. So somewhere up here. So if I push window, it shows me my x's go from a minimum of -10 to a max of 10. And it scales it by 1. So that means it counts 1, 2, 3, 4, 5, 6. You can scale it by 2, 2, 4, 6, 8, 10. You can change any of these. My y min goes from -10 to a y max of 10. Rescale it at 1. Well, we want to only really change the y max. I'm going to pick something a little higher than I kind of think it might be, but I'd rather pick higher than and not have to choose several numbers. So I'm going to plug in 30. And I'm going to push graph. And I'm just going to see if the point of intersection shows up. If not, I'm going to keep moving my y max higher. Ooh, and I barely got it. So it looks like it's right up there at the top. Okay, so we need to find this point of intersection. In order to do that, we're going to push second, and then I'm going to hit calc, which is the trace button here. And you guessed it, we're going to do number 5. Now your graphing calculator is very smart. However, there's some cases where like, okay, I've only graphed 2 lines, but your calculator doesn't really realize which lines you want to do. You can graph more than 2 lines. So it's first asking me right here, which curve is it? So anywhere on this blue line or your red line, wherever your cursor is, I'm going to push enter because this is telling the calculator, this line is the one I want. What's my second line? And you want to make sure now the red line is highlighted. So if I go back and forth, notice I'm using the up and down arrows here. It jumps from the blue line to the red line. And I want to, it doesn't matter where I push enter, I just need to tell it, hey calculator, this is the second line that I want to use to find the point of intersection. Then it says, okay, where do you think it is? And get somewhere close. It doesn't have to be super exact. It doesn't matter if I push enter here, here. So anywhere around there, because there can be more than one point of intersection. So you're telling your calculator, I want this one in this area. So then I push enter. Okay, here is my point of intersection. Okay, round any decimals to the nearest hundredth, and we're going to write our window down here, and we're going to draw a sketch of the graph. So we're going to do all those things over here in our calculator. So the first one, it's negative 2.84, nearest hundredth is the second decimal place, comma 26.62. So I'll go ahead and just write those answers in. So that is my solution, negative 2.84, comma 26.62. My graph, again, I'm going to do just a brief sketch of this. If you need to, keep referring back to your calculator. But again, it says a sketch, so we're going to do something that's a little off because it didn't go through the origin. It missed the origin. And if you want to do 2 separate colors, that's absolutely fine. That's not required. And remember, the only one we changed here was the Y max. We left the minimums and the maximum for the X's. We did not change the minimum for the Y, but we made this one be 30. So, this is the reason that most people don't actually use graphing to solve systems. It does not necessarily give you exact solutions, and it would be very difficult to do, very challenging to do, if you did not have a graphing calculator. Okay? All right, so some special cases. All right. All right, so when we do the special cases, we're going to look here at number 4. I want you to do one thing. Pause the video, solve this second equation for y. Go ahead and try to circle which one it is, and then we'll talk about it. Again, push play when you're done with that. Okay, so this is no solution. Hopefully you got y equals 2/3 x minus a half. There is a reason that I highlighted the negative a half in red. If you compare it to the equation above, y equals 2/3 x, the slopes are equal. The only thing that is different are the slopes. So if you the y-intercepts. If the slopes are the same, you have what kind of lines here, which is exactly what number 5 is. Perpendicular, same line, parallel, or intersecting. We actually have what we call parallel lines, which is the exact same reason. We have no solution here. These lines will never cross if you graph them. It will look something, again, I'm ballparking this, but it'll look something, oops, not that last one. Here's my X and Y axis. It'll look something like this. I did not draw that to scale by any means, but they will never cross. Okay, so again, that is when you have the same slope. Okay, but it's not the same line because they have different y-intercepts. All right, so let's try our next method of graphing here. But before we even do that, let's talk about solutions. Is the ordered pair a solution to the system? Let's do number 7. Well, in order to be a solution, it has to work in both equations, the first equation and the second equation. So I just need to simply plug it in. So if I plug it into the first one, does it equal 23. So I get negative 2 plus 10 equals 23 right away. No, that is not equal. So that answer is no. If I got 23 equals 23, then I need to move on to my second equation and try it. It has to work in both. It must work in both, not just one. Okay? Our second method of solving is substitution. Okay? We're going to try number 8 with this one. With this, you want to solve one of the equations for a variable. So solve one equation for x or y. Doesn't matter which one. Pick one. Well, I'm going to solve the first one. Neither one of them have variables, have numbers in front, coefficients. So pick one. I'll just solve it for, I don't know, I'll solve it for x. So subtract over a y. Now we're going to substitute. There's where the name comes from. I am simply going to plug in 4 minus y in for this x right here. So I'm going to have negative 5, and in parentheses, instead of writing x, I'm writing 4 minus y. And then we solve. So we can do it a couple different ways. I would probably choose to distribute here, though. I'm going to add over 20. Get that to be 14. Add there. And then we get y equals 2. So again, these should always be ordered pairs. Something comma 2 will be my solution here. Plug it back in. I can plug it back into any of these two. I can also plug it in right here. So if I do x equals 4 minus 2, I get that to be 2. So then my ordered pair is 2 comma 2. Okay? So problem like number 8, I had to do a little bit of an extra step. Problem like number 9, this is already set up for substitution because it's already solved for a variable. Okay? Elimination is the last method. Okay? Some people call this addition or subtraction as well. But again, it's the same sort of idea. What your ultimate goal is you're going to add equations and cancel a variable. So if I just added these two equations, I'd get 2x plus 3y. I can stop right there. No variable canceled. I didn't get one of these to be 0, and that's my goal. I want to make it 0 here. So what I need to do is decide, do I want to eliminate x or y? In this case, I'm going to choose to eliminate x. So if I multiply this first one by a negative 1, and the reason I'm doing that is because now I'll get negative x minus y equals negative 3. When I add these two equations right here, the second one, which I didn't have to do anything to, and this one, now my x's have the same number in front. One is positive and negative, so when I add those, 1 plus a negative 1, that becomes 0. It cancels out. I add here, I get that to be y, and then this equals 3. Sometimes I'll get that to be, 2y equals 6 or something like that, and I'll have to keep going. But you want to eliminate a variable. Then I can plug it, but now I'm kind of using substitution. Plug 3 back into one of those equations. I'm just choosing to plug it into the top one. Oops, I should not have that y there. I apologize for that. So that takes the place of the y. Subtract over. So x is 0. Let's try another elimination problem. Let's look at, let's do 13. Okay. Notice it's not set up in the same form as the previous problem we did, or even 12. X's are lined up, Y's are lined up, equals are lined up, constants are lined up. We need it to be in this format first. So before I can do anything, I need to get this y to the other side. Okay, so I first need to change my equation by subtracting over y. Now, I really didn't change it. That's not the correct word to use there. What I did is just rearrange the order so it's equivalent to the original. Okay, so now I'm going to choose to get rid of either x or y. You know, let's go ahead and just get rid of, in this case, let's choose y. Really shouldn't matter, but if I look at this y and I look at this y, I need one to be 3y and one to be negative 3y. So I can just multiply this equation by negative 3. And notice I'm multiplying it to everything. And I apologize, it shouldn't be negative. It should be just positive 3. Because this one's already positive. This needs to remain negative. So that would leave this as a positive 12, a negative 3y, and a negative 6. Now I'm going to take my first equation, write it below. Again, notice everything lines up. Constants, equals, y's, x's. Now I can add those. Oh, what's happening here? This is 0, and this is 0. So we get 0 equals 0. Well, think back to when we were solving just a single equation. Is this true? Yes, it is. What was our answer when we had true? Well, it was many solutions. This is going to be infinite solutions. If it was false, it was no solution. So what happens is, these are the exact same line. If I was going to graph this, I would get this line, and then I'd graph the other one, and it'd be right on top of the other line. Okay? So that's a special case. So your special cases are where you have infinite solutions or no solutions. Okay? And notice that you have directions like this for 14 and 15. Solve using whatever method you want. Graphing, substitution, elimination. I probably would not advise graphing. I would choose one of the other ones, but it's personal preference, whichever one you would like to do for those. Okay? All right, and then we are moving on here to some word problems. Let's take a look at this. Solve the word problem below. Write your answers in a complete sentence. I'm not looking for a paragraph or a page, just a complete sentence. Okay? And actually, I'm even okay if you just simply label it. I'll show you what I mean by that. Okay, so let's first take a look at this. You're selling tickets for a high school concert. Student tickets cost $4. General admission tickets cost $6. You sell 450 tickets and you collect $2,340. How many tickets of each type do you use? I'm going to highlight a couple things here. Money, money, money. So I'm probably going to put an equation together that has to deal with money. Student tickets are $4 and general admission are $6. That total should be $2,340. So if I do 4x plus 6y equals 2,340, this again is representing my money, but I do want to identify x is the number of student tickets and y is the number of general admission. So it's important to define those. Some people like to use maybe S and G because then it relates right to the problem. But again, it's super important to, again, realize what those variables stand for. The next thing is I see a total amount of tickets. So I got to think about, okay, how do I do a total amount of tickets? Well, literally the number of student tickets plus the number of general admission will be the total number. So literally x plus y would equal the total number of 450 tickets. Okay? All right, I would like you to choose any method you would like to solve this equation. Go ahead, pause the video, push play when you're ready to check your answers. Okay, I chose to do elimination and multiplied the green equation, the second equation, by a -4. Distributed through, added, I got y to be 270, and then when I substitute back in, I got x to be 180. Okay, so complete sentence, or again, just label. Here, this, knowing what your variables stand for will help you with this. I sold 180 student tickets, and also 270 general admission tickets. I'm okay with this type of an answer. Label, label, label. If you want to go ahead and write a complete sentence, totally fine. But again, you need to label it at least with a general phrase. That would be fine. Okay? All right, so this concludes the notes on solving system. So now you have a quizzes to do, and then you will have this to finish up for your homework and upload.